Radhe Radhe everyone. I think I'm live, right? Mm, just a little bit of checking and a little bit of promotions. After that, we will be starting with our video, okay? Excalibur, okay, everything is set up perfectly. Leetcode Biweekly, yeah, it is showing over here. I am live. So yeah, I think I'm live. I'll just share the link on Discord so that people can join quickly as possible. Okay, so yeah, I'm audible, right? Perfectly. I'm audible. I'm audible. Proper. Yeah. So let's start. Sum of good numbers. Okay. Given an array of integers nums and an integer k, an element nums I is considered good if it is strictly greater than the elements at indices I minus k and I plus k, if those indices exist. If neither of them exists, nums I is still considered to be good. We have to return the sum of all the good elements in the array. Okay, clear? Now see, I think like this is not that hard question to solve, but since like obviously like I think more any if someone is viewing this, just tell me, do you want me to explain it in Excalibur or just go through the code of this first one? If anyone is watching this right now, skip the no, I won't skip that. That's not the thing. Like, should I go with that or like that? What I mean is, okay, let me just explain it. Okay, let me just explain it quickly. Just code them, yeah. I'll just explain it quickly and then I'll just code it out. Okay. So first of all, I think I am couldn't connect to database if problem persists. I don't know what the heck is happening with Excalibur recently. It shows me there are 3 people, but obviously I'm the only one over here. Well, see, I don't think I need to go through the explanation for this. So basically, what I'm doing is I'm taking the nums, okay, and I'm having the k. So for every specific element, we are going to check if I minus k is a valid index or not, that is greater than equal to 0 or not, and if this is occurring, that is the condition that it is not good. Initially, I'm going to consider it's a good, okay, so it's good is true. So if nums I is lesser than equal to this, that means it is not strictly greater than that. So we can directly say that it's good is false. And if I plus k is in range and this is occurring, that means that it is also false. So only if it is true, then only I add it to the sum, and then I can return the sum and you get the answer. Okay, clear? Now let's move on to this problem. Okay, description. Separate squares 1. Okay, is my Excalibur working? Yeah. See, each squares I is equal to xi, yi, li. Okay, what we are given a 2D integer array called squares, and each of the squares has three things. One is the coordinate from which it starts, x of I, y of I, which represent the coordinate of the bottom left point. Okay. By the way, Arnav, how many questions did you do? We have to find the minimum y coordinate value of the horizontal line such that the area of squares above the line and below the line both are equal. Okay. But we were given a condition that just one. Okay. We were given a condition that 10 to the power minus 5, like we were given that the error can be adjusted with 10 to the power minus 5. So what does it mean? It means that whatever our answer is, it can be plus minus 10 to the minus 5, right? So let me just explain you what the whole thing is all about. So let's say there are this is the like graph. Okay, this is the graph of it. Now in this graph, what you are doing is, we know that there are various squares. Okay, so let's say one of the square is like this. I know this looks more like a rectangle, but yeah, one of the square is like this, another square is like this, another square is like this. Okay, so there are a lot of squares, and there are even overlapping squares. Okay, now we have to draw a line like this so that the areas of all the squares above this and the areas of all the squares below this is same. And even if it is not same, like we were given that we can have it to the 10 to the minus 5 thing, right? So that is what we are going to find out. So what is the minimum value of the y such that this and this are having the same area, right? Now how to do that? Let me get into a little bit of the depth of it. Okay. See, first of all, one thing, that whenever you're going to quote something, you have to go through the constants of it. So the constant tells us that nums of length is lesser than equal to 100 and nums of I is lesser than equal to 1000, right? And k is lesser than equal to, oh sorry, I messed it up, not the right one. We know that the length of the squares is lesser than equal to 5 into 10 to the power 4, and xi is lesser than equal to 10 to the power 9, and li is lesser than equal to 10 to the power 9. So whenever you find something that is 10 to the power 9, one thing, you can make it out from here, that we don't have to make any algorithm. I have a question. Suppose you have coding assessment of technical in 1 week, like code beta kind of. So how would you prepare revise in last week? Code beta. When is the code beta though? See, I won't be flexing it out, but the previous code beta I had a rank within 50. Okay, top 50. The round one, not the round two. Round two I had, like, I was down with fever, so I couldn't do it. So it's like, if you're practicing every day, I think it's more than enough. I mean, not every day, like how I practice, that is like every contest, almost every contest I'm giving, right? So if you're like following me and giving most of the contests specifically on Code Forces, Leetcode, and Code Chef, some days, like keeping some of the days off, I think it's good enough. Okay. So let's get into the question. So now square's length is 10 to the power 4, right? Now from here, a very important thing that you can take out is that if anything is of 10 to the power 4, that is the n value, always remember that we have to keep the values lesser than equal to, or let's say lesser than equal to 10 to the power 7 or 10 to the power 6. Okay, any one of them. Sorry, 7 or 6. Okay, so we have to keep it way lesser than them, which also concludes that the whole thing which also concludes that the whole thing over here, whatever we are going to discuss, it should be in big O n log n. Okay, right? Now see, the n thing, it is very much similar that this is going to be the traversal, right? This is a traversal of the whole all the squares. Okay, but this log n, so this log n is going to find out the value of y, right? Now since this log n is going to find out the value of y, we can say one thing very clearly, that we go a little bit down, that we can have a binary search, right? Because binary search is something which gives us a log n complexity, right? So what we can do is we can binary search, but the question is on what, right? On what can we binary search? Now since we know that the binary search result is going to give me the minimum value of y, which is going to satisfy the whole thing, right? So in that case, one thing that you can directly say is that we are going to binary search the value of y, where the lowest value can be 0. Okay, because over here, yeah, it may happen that the lowest value is 0, but it won't be. It's like it won't be, but it can't be lesser than 0, right? So that is what I mean when I am telling that the lowest value can be 0. Otherwise, the highest value can be the highest value, the highest position where the last square occurs, right? So what is the r? R is basically the last square's coordinate. It's not the coordinate, because like whenever I'm talking about a square, the coordinate is basically this. So this r is going to be basically nothing but, this is, let's say, y of I. So r is going to be the maximum value of r of I plus length. Okay, what do I mean by that? It is square of I of y, right? Yeah, I of 1 plus square of I of 2. Okay, so we have to find out the maximum of this. Like for every specific element, whatever the values are coming, we have to find out the maximum of this. Now we have got L and R. Now if I'm going for some binary search, that is mid, right? What you have to do is you have to consider that this mid is the value of the y. Mid is a new value of y. Now putting that into consideration, you were having a lot of squares, right? Now let's say the mid is over here. Okay, now from here, let's say this is 1, this is 1, and this is 1. So what is the sum of the squares above that line? It is 2. And what is below that line? It is 1, right? So now what we have to do is we are going to search over here, right? But now there is also an interesting condition. Okay, that is, what should be the value of the new r going to be? Because obviously we know that this is not the value, right? This is not the value. So should we be like searching for this and this? Sorry, this and this. Are we going to find the binary search for this and this? This and this, right? We are not going to do that, because we know that whenever we are going to go for some binary search, we do either r is equal to mid minus 1 or L is equal to mid plus 1, right? That is what we basically do. Plus 1, right? Now in this case, this 1 is not going to be valid. Why? Because in the question we were given that the error can be 10 to the power minus 5. So this is the most important thing. Now since the error can be 10 to the power minus 5, so we have to take it to be 10 to the power minus 6 to be more accurate. So that 10 to the power minus 5, this thing is not much hampered. Okay. So this is basically going to be replaced with 10 to the power minus 6. Clear? Let me use a different color. I think I am using the same color. So 10 to the power minus 6. Okay, clear? Now see, this is one condition, right? We can do it like this. This is very simple. Just find out all the squares above it, and then find all the squares below it. But what if you're having a square like this and also one square like this, but the line, the midpoint is somewhere like this. So in that case, you have to consider for the below thing, for this part. So let's say I'm using a different color code. For the below part, I'm going to use the orange color. Okay. So for the below, it is going to be orange, and for the above, it's going to be green, right? So these are green. So we have to make the orange and green equal, right? We have to make the orange and green equal. Now, since we, like, you get the basic idea what we are going to do. We are going to perform a binary search. First thing, we are going to perform the binary search. Second thing, in the binary search are the mid minus 1 and mid plus 1 is going to be replaced by mid minus 10 to the power minus 6, mid plus 10 to the power minus 6. Done, clear. And now we also know that if there is a square through which the y-axis, y is equal to mid, okay, this is y is equal to mid basically, through which the y is equal to mid line passes. So in that case, whatever comes below that, we are going to consider that area for the below, and whatever comes above that, we are going to consider that for the area above. Okay. Well, how we are going to do that, right? It's basic, very simple mathematics. So let's say if you're having a square, and this is going to be x comma y, and this is, I'll use a different color actually. This is L. Okay, this is L, and the axis, it goes like this, right? So what we have to do is we have to find the coordinate at this position. At this position, what is it going to be? So let's say this is, sorry, this is y is equal to mid, right? Y is equal to mid. So what is the coordinate of this going to be? It is going to be x plus L comma mid, right? I think that it is not visible for you, but yeah, it is mid. Okay. Now see, since it is going to be x plus L mid, so what you can do is you can find out the area for both of them. How can you find out the area for the orange area? It is going to be L into mid minus y, right? And for the green area, it is going to be L into, no, not mid, y plus L minus mid. Okay. So you get both of them. So what you can do is for the all the areas below the line, you're going to add it up to a variable called, let's say, down. Okay, let's say down, or rather let me make it like this. Let's say down, you're going to add up to this, and up you're going to add up to this. Okay, clear? Now what is the binary search condition going to be? It is going to be up is equal to down, right? Because you have to make it as equal as possible. But yeah, one more thing, we have to find out whichever is the minimum thing, the most minimum thing. So that is the reason, if it is equal to, but you can go more down, so go for it. Okay, I think now, is it clear? First of all, let me, like, someone just clarify if it is clear or not, whoever is watching this. Okay, is it clear till now? Clear. Okay, great. So let's get into the code. Okay, see, L is equal to 0, R is equal to 0, answer is equal to 0. Anyways, people who are watching this, just subscribe my channel. So yeah, that's it. So yeah, L is equal to 0, R is equal to 0, answer is equal to 0. Initially, everything is 0. N is equal to square root size. What we are going to do, R is going to be the maximum of, I just saved, It is going to be squares of I1 plus squares of I2, right? Clear? Answer is equal to R. Clear? While L is lesser than equal to R, binary search. Mid is equal to R minus L by 2 plus L. That is L plus R by 2. Okay? Just to avoid the overflow thing. Clear? Up is equal to 0, down is equal to 0. What is up and down? I just mentioned up and down. Okay? Clear? Now, x1, y1 and x2, y2, right? So what is x1, y1? X1, y1 is basically, let's say, okay, let me just do it. If you're having a square, so this is x1, y1 and this is x2, y2. Clear? You know that it is a square, so x2 is equal to x1 plus L, y2 is equal to y1 plus L. Clear? You can check it out from here. X1 is this, y1 is this, and x2 is this plus L. Okay, I think it is not completely visible. Yeah, this plus L, and y2 is this plus L. Okay, clear? There are various conditions. What are the various conditions? If y1 lesser than equal to mid and y2 lesser than equal to mid, if y1 greater than equal to mid and y2 greater than equal to mid, else. So what does it mean? It means that the line, the mid line, it can be either on top of it. So if it is on top of it, the whole area of the square is to be counted with down, right? And if it is on bottom of it, the whole area has to be counted as up. So these are the two conditions. And the third condition is if it is going to be passed through it. So the upper area of the square is going to be on up and lower area is going to be down. Okay. So initially, if this is the condition, then the whole area is going to be contributing to the down. Otherwise, it is going to be contributed to the up. Okay. Otherwise, what happens? Down is contributed with mid minus y1 and up is contributed with y2 minus mid. Okay. This is it. Y2 minus mid and mid minus y1. Okay. Clear? If up is lesser than equal to down, why do I do this? That up is lesser than equal to down, because just now I just mentioned you that we have to minimize the value of y for the mid. Okay, so if it is lesser than equal to down, you can directly say that the answer is equal to mid. Okay, because the answer should be as low as possible. So answer is equal to mid. R is equal to mid minus 10 to the power minus 6, else L is equal to mid plus 10 to the power minus 6. Is the whole code clear according to the explanation that I just went through? If it is clear, then I'll move on to the third question, which even I haven't solved. I don't know how to go through the discuss of code. How do I find the discuss? Clear, right? Where do I find the discuss? Can anyone summarize once more? Please, stream is lagging a lot. Stream is lagging a lot? It is still lagging. It is still lagging. No, over here it seems that it is good, right? Just let me check, okay, how many frames did it drop? Okay, 196 frames. That means like somewhere between there was a little bit of lag, right? Not that much, I guess. There was 0.4% drop frames, and it is like 3108 kbps, which is well and good enough for it. Yeah, the CPU is like it's working too much, and yeah, the frames are also 30 fps. So I think not that much lag, right? A little part of I think that was a lag. Summarize once more, please. Stream is lagging. Anyways, yeah, I will summarize it. Shit. instead of pressing it, I just press the cancel. Okay, so what do you want me to summarize though? The code part or the whole thing? Mm-hmm. What do you want me to sum? The code, okay. See, the code is very simple. Like if you get the whole thing, you will also get this. Okay. I'm having the value of L, R, answer. R is the maximum of squares of I1 plus squares of I2, right? We know that. Answer is equal to R. I'm just making the answer as large as possible initially. You can skip this line also, okay? It doesn't matter. While L is lesser than equal to R, that is simple binary search. Mid is equal to R minus L by 2.0 plus L, that is L plus R by 2. Just ignoring the overflow. Up is equal to 0, down is equal to 0. What is up? The sum of areas above the line and sum of areas below the line, up and down, okay? Now you go through all the elements of squares and you find the value of x1, y1 and x2, y2. What is x1, y1 and what is x1, x2, y2? x1, y1 is this point and x2, y2 is this point, okay? Yeah, there was a lag, I know. So these are the 2 points, okay? Now, there are various conditions. That is, either the line can be going through just the middle, or the line can be above it, or the line can be below it, right? So for all the three conditions, we are having different like ways to handle it. So if the line is well above it, so the whole area of the square is going to be in the down, right? And if it is completely below it, so the whole area is going to be added to up. And if it is passing between it, so one is going to be mid minus y1 and another is going to be y2 minus mid, okay? That is because this point in this case, like if you go through this, we just went through the formula. One is going to be mid minus y and the other is going to be y plus L minus mid, and you know y plus L is basically y2, right? Because we have done it. Now there is also one more condition, that if up is lesser than equal to down. Why do I go for lesser than equal to? Because it was also given in the question that we have to keep the mid as low as possible. But BCD was way too above head for me. What should I do? Just a minute, huh? I'll just explain the whole thing. So answer is equal to mid, and the simple condition R is equal to mid minus that and L is equal to mid plus that. So what is this? This is basically 10 to the minus 6, okay? Because we were given that the error is okay if it is between 10 to the minus 5. So we just went one way ahead. So anything, so even this was, instead of this 1, even if we wrote it to be 5 also, I think that would be well and good enough, okay? So we had to make a number which is way lesser than 10 to the minus 5. That is what we were needing it, okay? So that's it. Now is it clear or no? See, I was able to solve A, but BCD was way too above head for me. What should I do? See, as a beginner, I will tell you that the level between A and B, yeah, clear. The level between A and B was well ahead. Okay, it was very large. The difference, the level difference. So yeah, it is very much normal. But this binary search, like if you want to go, like if you want to understand that how to solve a problem, so first thing that you need to look into it is its constraints, and then like there is always a kind of list that you can make out of it. That is, if the the value of n is of range 10 to the 5, so it means that we have to go for n log n approach, okay? And n log n usually tells us that n can be the whole traversal and log n can be a binary search. This is a very common thing, okay? This is a very common comparative programming algorithm that you have to go through. That is, whenever we are finding that it is 10 to the 5, it means n log n, and in various cases n is the traversal and log n is the binary search. Clear? So doing this, you can get a basic idea of what I mean. Now see, what is separate squares 2? I won't be going through the whole question again because the question is same, apart from the fact that over here we just explained that if there is a overlapping area, so what should we have done? We should have ignored that, right? But what we were doing is instead we were considering the area of this square plus the area of this square, right? Which means the overlapping area, it was getting considered twice or sometimes even more than that, right? Let's say there is another square. You never know, right? There is another square. So in that case, it is going to be getting there thrice, and this area is going to be twice. Okay, various complex things are going to happen. This area is going to be twice, so somewhat like that. Okay, so we now have to eliminate those overlapping areas. What was needed in basically separate squares too. How to do it? I don't know. I will go through the discuss. Okay. Because yeah, like it's like I, as you guys know that I'm streaming after a very long time. So yeah, it's getting me a little bit of, I'm a little bit of out of my practice, right? Simplest solution. I think there was a lag again, right? Yeah, there was a lag again. 563, 1% frame drop. Now I think it is okay, right? Or maybe my voice is proper, but some lagging. So, yeah. Anyways, this is my code. You don't have to look into it because it is wrong. Okay. Let's see what he has done. Okay. Holy Christ. Oh, I think this is not my code. Okay, this is his code only. Compute unique area, but it seems to be like my code. I was able to figure out how to solve second question, but got stuck with the precision stuff. Uh, it's like you can experiment with it. Like even I was experimenting it with it. If you notice that I got one wrong answer and one time limit exceeded. After that, I came with the accepted solution. Okay. So yeah, sometimes you need to experiment with it. Okay, he has used segment tree to do it. Okay. Save a copy of input in learn tree vec C. Same for you too. Did you guys get like what I explained for the B, Prajwal and crazy channel guy? And Prajwal, do you like are you doing coding a lot? Then I'll just go through your channel and like we can have a channel review kind of thing at the end of this video. Okay. Okay. See what basically this guy is doing is he's using the sweep line in y direction, which is somewhat what I have also done, but I think I was getting a TLE on this. Yeah, I was getting a TLE on this. 9 of the test cases were not getting solved because of the TLE. Even I was doing this, but this guy came up with it. Great. But I think this is a completely chat GPT generated code. Oh, okay. That is exactly what I'm thinking, right? Because yeah, this solution was out there. The solution was out there, and I just asked ChatGPT how to do it. And he gave me something. I was just experimenting with it. Wow. Yeah, you get it. Is there any like proper solution for this? I think the Java one is good. Loon tree See, whenever you find that there is some variable called like this or something like very unique, so you know one thing that it is generated by ChatGPT. Okay. I was just thinking about that. Like, does that mean that it was my code or like this code? Because this is a code that I was doing after the contest, right? And like, it looks so same. So yeah, most of it is more copy paste only. So I think I'll just go through it. I'll just go through it and I'll just explain you when I'm getting the whole solution. Because obviously a copy paste code is they're just doing it for views, right? They have got no explanation on this, no explanation. Even time complexity and space complexity is blank. Sorry, I'll just go through it, okay? And for this code, I'll just go through and discuss again. Well, I think I should explain you what the whole question is about. This thing, shortest matching substring. I won't read out through it. I'll just tell you what it is about. You're given two strings S and P, and in P there are two stars. Okay, it is simple. It is similar to regular expressions. Okay, where a star can be replaced with any number of characters. So you have to find out what is the smallest substring which has that pattern. Okay. So what I came up with the idea is that if P is starting with a star and ending with a star, okay. So in that case, we just need to find out whatever is between that. You have to find it out in S, okay. And if it is there, then this is the length of the whole thing. Okay, clear? But well, what if it is not the case, right? Let's say it is ending with a star, but it is not starting with a star. So in that case, we have to find out all the positions where this is occurring and all the positions where this is occurring. Okay. And we have to find out the nearest for every this, we have to find out which is the nearest one that has occurred like this. So which basically means that let's say if I'm having a array which is going to store me like at what positions this occurred. Okay. So let's say for there are various positions, and if for some position it occurs, it is going to be making it true. Okay. And the remaining positions are false. Clear? Now what we can do is we can like whenever we are going to traverse through it, and whenever we find a true, we can simply say that this is the last position that it has occurred. And we are also going to have a different array where instead of this we are going to consider this. Okay. So that thing also we can have some false true, false true, false false, somewhat like that. Okay. So whenever we are encountering this true and then we are encountering this true, right? So we know that the distance from this to this is a valid thing. So we can store that as an answer. Then whenever we find the next true, and since we have already traversed through this true, so length, this length is also a valid thing. So for all the such valid conditions, we have to find out that what is the minimum length for that. And the same thing you can do if the opposite thing occurs, that is it is starting with a star but not ending with a star. Okay, starting with a star but not ending with a star. So in that case also the same thing, this and this. Okay, for this one array, for this another array. But the main problem occurs when both the stars are not in the middle. I mean both the stars in the middle, right? So if both the stars in the middle, so in that case you have to go for three arrays, and which is going to be a little bit complex for you. So yeah, that is somewhere like it is going to be difficult. So in that case what you can do is simply you have an array for this, okay, you have something for this, okay, and then you have an array for this. So let's say true, false, true, false, true, true, false, false, true, true, true. Now see, now whenever you're going to make this array, so this is the last array that you're going to make, okay? So whenever you're going to make this array, what you're going to basically do is you're going to find out what is the previous position that it occurred and save that, okay? Save that, and you have that array ready. Now again what we have to do is we have to find out what is the last position that it occurred and then save that as plus, okay? So you can get the whole thing. I know whatever I am explaining, it is a little bit high level. The first three conditions I think it was very easy, but the last condition that I'm explaining I think it is very high level. So if it is not clear, just write in the comment section, okay? It is not clear, and if it is clear, just write in the chat it's clear, okay? If you want an example, let me go with an example. Let's say S is, no, I'll just use a different color. I'll use black. So let's say S is some string, okay, and P is a string where there is a star over here and a star over here. So for this occurs in S over here, over here, over here, over here, okay. So these positions, the starting positions, you can write it as true, okay, and this occurs over here, here, and here, okay, right? So that those positions we can write as true, okay, the starting positions. And whenever we are going back to just this middle position, now this occurs, let's say somewhere over here, which means what we have to do is we have to find out what is the last position where the black occurred, okay? What is the last position where the black occurred before this? It is this one, okay? I'll just use a different color, blue. So it is this one. And what is the last position? I mean, what is the first position after the red one for the yellow? It is this position, right? So this. So basically this whole thing, it is a valid substring. Okay, clear what we mean, what I mean by it. I think it is clear. But there is also another exceptional case, that is a case where I was getting stuck with, because of which I was getting a wrong answer. That is, if both the stars are together, so in that case there is nothing in middle, right? The middle element is blank. So I don't have to make a array for red anymore. So in that case I can treat both the stars as just one star, okay? And the same thing I can do for the as I was doing for the first one, that is find this and this, just two arrays. So this is also an exceptional case, but which can be solved with one of the cases that I have already explained. So if you go through all the cases completely, you can make out a solution of it, but I couldn't do it within the specific time because I took a lot of time on this separate squares too, so I couldn't do it. Yeah, but I think you can go for it. And yeah, one more thing, like pattern matching. Obviously, you won't be using something very complex. You can use a k map or a z function. Okay, you can use a z function or a k map. I think, yeah, k map. It's not k map. Sorry, not k map. KMP. Okay, you can use a KMP. So you can go through the solutions. Yeah, three pointers. Three pointers. I think it is because of the fact that 1, 2, 3. That is this one. 1, 2, 3. Right. Well, I think it is well and good enough. Let us come to the last part of today's live stream, that is rating the problems, right? Easy, not hard. Medium, hard. Okay, see, the first one was easy, second one was medium, third one was somewhat between C and this. No, I think the third one was hard, man. Like coming up with a solution for that is hard, and D was hard, which is like very much equivalent to what the whole today's like today. I think the whole thing was justified. The rating of the problems. This was given a medium. This was given a easy, if I'm not wrong. Yeah, this was given a hard, I guess. Yeah, this was given a hard, and this was also given a hard, I guess. Yeah. So like it's basically like yeah, all the problems were hard enough. I mean, all the problems were justified. But like if you're very much well accustomed with z functions, so I think this won't be a much harder problem. But I'm really amazed to see that there are 686 submissions over here with 638 users. This is 1438, like still okay because Chat GPT can code you down the z function, but so many valid situations, so many valid conditions for this one. Don't know. Okay, so yeah, that's it from my side. Thank you. Good night. And tomorrow, I think I will be streaming for the Leetcode weekly contest or at 9:30 a.m. So yeah, join it. Okay. So that's it from my side. Thank you. Radhe Radhe.